Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on single phase half-wave uncontrolled rectifier in that RL load and RL with freewheeling diode. So first here the types of classifications already we discussed. Here that there are two types of rectifiers. So first one is single phase rectifier and three phase rectifier. In the single phase rectifier, half wave rectifier, and next full wave rectifier. In this again in the three phase also half wave and full wave rectifier. Now here in this uncontrolled single phase half wave uncontrolled rectifier, and now here in this we discussed R load, L load. So today we are going to discuss with RL. Resistor inductors are connected in series, and now here resistor inductors are connected in series with freewheeling diode. In the next lecture I will explain RE and RLE type of load. So same fashion for controlled rectifier. So in the uncontrolled rectifiers we will use only diodes. In this we will use thyristors. Now here in the full wave rectifiers, controlled rectifier, uncontrolled rectifiers and semi-controlled. So now these are the different types of loads. So now here in the half wave uncontrolled and controlled rectifiers, in this only controlled rectifiers. So these are the classification of rectifiers. So in the last lecture we discussed only R and L type of load for single phase half wave uncontrolled rectifier RL load. So now here single phase half wave uncontrolled rectifier with RL load we are going to discuss. RL load means resistor and inductors. R and L are connected in series. So this is the load. For this particular load, output voltage, output current and diode voltage, and that output voltage equation formula and output current formula, average value, RMS value and diode, and what is the conduction angle for diode, and what about extension angle, and next peak inverse voltage for this particular two types of load, R load and L type of load. So now here I am giving the supply voltage V equals to Vm sin V equals to Vs equals supply voltage Vs equals to Vm sin omega t. So here it is a Vm sin omega t. So this is a Vm sin omega t. Vm sin omega t. So now here this is a maximum voltage Vm. So now here maximum voltage Vm. So now here I am giving the load voltage. So first here how it will works. So in the uncontrolled rectifier we will use the thyristors. Here I am using the diode only. So Vd is the voltage across the diode. That waveform I will show you. And voltage output, this is the load, RL load. So that output voltage and output current. So output voltage and output current. And this is the supply voltage Vs is given. So how it will works. So now from the 0 to pi. 0 to pi. And now here from the pi to beta. And beta to 2 pi I am giving. So this is the pi and this is the 2 pi. Here suppose of beta. Beta value is depending upon the value of magnitude of the inductance value. First how it will work. So first one is here what is the output voltage. So from 0 to pi. So the diode is in forward bias. So the diode is in forward bias. Anode voltage is greater than the cathode voltage. So in this case, so the diode acts as a short circuit, and now output voltage equals to supply voltage. Now here what about the output current equals to I naught equals to V by Z. And now here V naught by Z means square root of R square plus omega L whole square XL square. This is the output current. So this current should be like this. And now here from the what about the diode current? Diode is a short circuit from the zero. So V of V naught equals to Vs, I naught equals to this V naught by R square plus omega L whole square under root, and ID equals to 0, Vd equals to 0. This is the case for 0 to pi. And now here from the pi to beta, so pi to beta also, so here inductor stores the energy in the form of magnetic field. So that energy is come back to the from the load to the source. So now here in this case from the 0 to beta it is also conduct. Then and now here this is current is discharging. So now here this current will discharges up to beta. Now here in this case also the diode is in reverse bias, Vd equals to 0. So now here V naught equals to Vs, I naught equals to same V naught by R square plus omega L square whole square, and Vr equals to 0. So now what about the beta to pi? Beta to pi is in this case, so the Vk is greater than Va, and the diode voltage equals Vd equals to Vs, and V naught equals to 0, and I naught equals to also 0. So now this voltage is output voltage is 0, and now here this output current is 0, and now here in this case the diode is in open circuit voltage. That diode voltage equals, it will follow the supply voltage. So this is the case again after 2 pi. So now here is also same. So now here is also same. Here is also same like this. This is for 2 cycles. Up to here 1 complete cycle. Up to here 1 complete cycle. So now here what is the extension angle? Beta equals for R load, for L load, and RL load. So these 3 cases I will explain. For what is the conduction angle? So beta is conducting in the R load up to pi. For L load up to 2 pi. So but here in this RL type of load, pi to 2 pi only. So beta is from the pi to 2 pi only, beta value. The extension angle, up to what angle the diode is conducting. So this is the important, that the beta value is in between pi to 2 pi only. And now here gamma of the conduction angle of diode is here. The conduction the maximum value of diode in the RL case at pi by 2 only. Now here in this case pi, here in this case the maximum value is pi by 2 to pi. So conduction angle, that maximum value of diode output voltage. So this is this one. And now here next case, what is the value of average value? Average value, here you can write here average value. Average value. So here this is the case, and next up to here only, sorry. And now here this is the case. Now next case here, V naught average equals to from 1 by 2 pi, 1 by 2 pi. So this is the beta, 0 to beta Vm sin omega t. So if you simplify this, Vm by 2 pi 1 minus cos beta. So now here V naught average value equals to I naught average value equals to V naught average divided by Z. So that Z equals to R square plus square root of R square plus omega L square. This I naught equals. So now here Vd equals to 0. Now here V naught RMS value. Now here what about the conduction angle? Conduction angle of diode equals to beta, and extension angle equals to beta. And now here peak inverse voltage equals to minus Vm. So this is the case. So now here in this case from the 0 to pi, so the power is transferred from the source to the load. Power is transferred from the load and pi to beta, source to the load, from power is transferred from load to the source. So now here let me change the color over here. So this is the case. So this is from. So now here in this case Vs is greater than 0, Is is greater than 0, and now here in this case P not equals to 0. Is greater than 0. But here in this case Vs is less than. So Vs is less than 0 and I naught is positive. But P naught is negative. So because of negative power, so it is transferred from the load to the source from pi to beta. So this is the case for a single phase half wave uncontrolled rectifier with RL type of load. So average output voltage and average output current and diode current and peak inverse voltage and beta extension angle. And now here circuit turn off time means here time for which omega tc equals to, what is the value? So pi minus beta only, the time for which the diode is in reverse bias, 2 pi minus beta. So tc equals to 2 pi minus beta by omega. So now peak inverse voltage is minus Vm. So extension angle and conduction angle, diode is conducting up to beta only. Now here next case, this is the case. Next single phase half wave uncontrolled rectifier with freewheeling diode. In the freewheeling diode case, so FWD means freewheeling diode. So now here what will happen? So first see the diagram. I am giving the supply voltage to this V0, I0 and diode. So this is a V0 output voltage, and output current, diode current and output voltage, and supply voltage equals Vs equals to Vm sin omega t. This is the case, Vm sin omega t. So now here this is a maximum value. So now this is a pi, this is a 2 pi, and now here 3 pi and 4 pi, 2 cycles I am taking. So now first I am applying from 0 to pi. 0 to pi, so what will happen? It will follow the supply voltage. So output voltage follows the so here in this case 0 to pi, freewheeling diode, this freewheeling diode is in FWD is in reverse bias. Vs is greater than the VA is greater than the VK. Anode voltage is greater than cathode voltage, and supply voltage equals to Vs equals to Vm sin omega t. Vs equals to Vm sin omega t. Now what will happen? Supply voltage V0 equals to, in this case this is open circuit, so it acts as an open circuit. So V0 equals to Vs equals to Vm sin omega t. It will follow the supply voltage. After in this case Vd equals to 0. This is V0 output voltage. Vs equals to 0. What about the current? So this current is up to here. Now here pi to 2 pi. So what will happen? Here continuous conduction mode is possible in this case freewheeling diode. So what is in the pi to beta? So from pi to 2 pi, what will happen? So pi to 2 pi, so it acts as a short circuit. and it will be open circuit. So it will be open. It is short circuit means, so it is open circuit. Vd equals to Vs. So now here in this case, so freewheeling diode is in forward bias, so that is it acts as a short circuit. In this case it acts as a open circuit. So now here what will happen, so Vk is less than the Vk, Va is greater than the Va is less than the Vk, and now here Vs equals to Vm sin omega t only, and output voltage equals to 0. So this voltage is 0 from pi to 2 pi. But here, because of this continuous this freewheeling diode, so this diode is acts this during pi to 2 pi. So this current is freewheels, so it will not be 0. So continuous current is possible. Continuous current mode is possible in case of freewheeling diode. And now here this Vd equals to Vm sin omega t. So it is short circuit, so Vd equals to Vs, Vm sin omega t, that equals to Vs. So this is the case. And next cycle, so it is this one and this one. So here current is not 0, always it is continuous. The previous one discontinuous conduction mode, and now here it is 0, and now here this one. So now here this is a case, so here V naught average equals to 1 by 2 pi integral of 0 to pi Vm sin omega t. That means equals to 1 by 2 pi Vm sin omega t means, here if you simplify this one, so that equals Vm by pi only, V naught equals to. And what about the diode voltage? So Vd peak inverse voltage equals to minus Vm only. This is a minus Vm only. And now here what about the conduction angle? So gamma of D equals to up to pi only the diode is in conduct. After that it will not conduct. So now here what about the extension angle? Extension angle beta equals to 2 pi. For all the cases it will be conducted. So up to beta, it is conduction mode. So these are the possibilities. So now here I am giving the first 4 advantages of freewheeling diode. So first one is the advantages of freewheeling diode. So first one is a output voltage is always positive. Output voltage is always positive. This is important case. And next, output voltage never be negative, always positive. And next, second case, continuous conduction mode is possible. Continuous conduction mode is possible. Continuous conduction mode is possible. Remaining all the cases, there is a discontinuous conduction mode. Current is sometimes 0, but here the current never be 0. And third point is output voltage V naught average is increases. And fourth point is output voltage is increases means input power factor is also increases. Output voltage is increases means output power equals to output power is also increases. These are the 5 advantages. First advantage is output voltage is always positive. It should not be negative even though inductor is present in the circuit. And next case, here continuous conduction mode is possible. Output voltage will be, if it is a negative means this part will be reduces, so it is symmetrical, so only this much amount of power is average value. So here output voltage will be improves, output voltage is increases. Output voltage increases means P naught equals to V average into and I naught average. So this is increasing means output voltage is also increases. And now here IS Vs cos phi equals to V naught average into I naught average. This is increases means so cos phi is directly proportional to the V naught average. It is increasing means cos phi input power factor is also increases. Output voltage is always positive and continuous conduction mode is possible. And now here input power factor is improves and output power is increases. So now here let me write the all the equations. So now here V naught average equals to V naught Vm by pi, and now here Vm by pi, and peak inverse voltage equals to minus Vm. So peak inverse voltage is minus Vm. This one. And now here first question, second question, and third question is what will happen. Third question, it conducts third is gamma of d equals to pi only. It is conducting up to pi only. And now here beta equals to 2 pi. And now here what about the conduction angle? The maximum value of output voltage is at pi by 2 only. And now here the maximum value of output current is in between this pi to 2 pi. And now here these are the four most important and advantages of freewheeling diode. So freewheeling diode is conducting from pi to 2 pi only. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.